Hey everyone, in today's lab we're going to be looking at Archimedes' principle and the effects that a fluid has on a submerged object. To begin, let's take a look at the different equipment that we have for this lab. Over on this side we have a tub of soapy water. The soap is actually going to be useful to remove the surface tension of water. But we are also going to have to be extra careful today to not provide too much bubbles. We also have a series of graduated cylinders, all of different volume and different levels of precision. We have two plastic cups of different size. We have a series of different masses, a force sensor, an overflow can, and a triple beam balance. To start this lab, we're going to fill up our overflow can with soap water until it begins to overflow through this side spout. To do this, let's take one of our larger plastic cups and take our smaller plastic cup and get ready to catch some water. Dip the plastic cup into the soapy water, but also try not to get too many bubbles in it. Begin to slowly pour the water into the overflow can several times until it begins to overflow. All right, when you get a nice consistent stream of overflow, you want to wait a few seconds for that stream to end. All right, so when the dripping has mostly stopped, we're going to go ahead and take that overflow and pour it carefully back into the basin. Now we're ready to begin. So please open up the Capstone software and make sure that you're connected to your force sensor. Click record to begin collecting force values. Now here we see that we just have a string and a paper clip being hung from it, but we want to calibrate the sensor to where this is a result of 0 newtons. On the side of the force sensor, you will see a button that says 0. Please press it to where it zeros. Now in this lab, we're going to collect a few important data points. We're first going to want to get the weight of each and every one of our masses. This can simply be done by hanging it on the force sensor. All right, so my mass here has a weight of about 0.99 newtons. We are also going to want to get the weight of each of our graduated cylinders while there is nothing inside of them. To do this, you can't hang it on the force sensor because there's really not an easy way to do that. So you're going to have to acquire the mass via the triple beam balance and calculate the weight of each graduated cylinder. Keep these weights in mind because they will need to be taken into account in a future part. On the write-up, we're going to record the weight of our object as seen earlier. So that was about 0.99 newtons. Next, we are slowly going to lower this mass into the overflow can, but this time we want to catch that water in one of our 3 graduated cylinders. We're going to leave it up to you which graduated cylinder to use for each mass. I'm going to opt to use this one for this particular mass, and I'm going to level it right here. This can actually be useful to have at least 2 people coordinate this. Have one person loosen the bolt on this end to where the bar is free to move, and then begin to slowly lower the mass into the overflow can. You want to do this slowly as to not have any of the water go over the top of the can. You only want it to come out of that spout. You're going to lower it until the entire mass has been submerged in the fluid. Now over on our computer, while this is leaking, we want to keep in mind how much force we are now recording. Observe that this is different than the weight of the object. Once the dripping for the most part has stopped, we're going to now measure how much volume of water has come out of the overflow can. We're going to record that volume as being equivalent to the volume of the entire submerged object because we submerged it the entire way. We then want to acquire the weight of this water by placing it back on the triple beam balance. And all of this data would then be recorded on our table. So let's notice how our new tension in the rope is 0.88 as opposed to 0.99. So over on our table, we're going to type 0.88 newtons. And now we want to try to understand where the difference is coming from. Earlier, it was pulling down on the string with a force of 0.99, but now it's only pulling down on the string with a force of 0.88. That must mean that on the object, there is an upwards force that is equivalent to the difference of these 2 forces. So in this particular case, we have this upwards force, which is called a buoyant force, of 0.11 newtons. We then want to measure what the volume of the water that was displaced is. I'll let you guys do that part, as well as take the weight of the water by placing the graduated cylinder on the triple beam balance, but also subtracting the weight of the graduated cylinder without any fluid in it. Once you acquire that weight, you would place it into this final column. You're then going to do this again for several different cylinders and create 2 different graphs. You're going to first create a graph that shows what kind of relationship exists between the buoyant force that we're calculating to the volume of the water that exits the overflow can when you place the object in. You're also going to create another relationship that expresses the connection between the weight of the water that is displaced to the value of the buoyant force. And once you collect all your necessary data, please go ahead and answer the questions at the end of the lab and begin your quiz. Good luck, everyone.